Let's derive few mathematical expressions that would help us in calculating impulse. So first case is provided we know average force is known. So what is the impulse? That's what we are trying to figure out. So what we have here is if, let me write it a bit neater, if AV is going to represent your average force applied during T1 to T2, then the impulse will be as per the definition. We have this, right? Since FAV is constant, what can we do? We'll just go out and all we are left out with dV, because this is constant. Average is a constant number, is it not? For a given situation, average is a constant, so it will go out of integration. And now we have, sorry, not dV, I don't know why I wrote dV, dt, and now we are looking at FAV. Integration of dt is t, so t2 minus t1. Basically, this is delta t. So impulse is equal to, it's kind of common sense, right? We have seen impulse in action. So we have seen this, right? So if I know this average somewhere over here, if we happen to know this value, it is approximately somewhere over here itself. Maybe around there. So that can be your average. So we know this is delta t. So basically the area under this particular graph, that is your impulse. Okay guys, so that is one situation. The other situation is impulse in terms of momentum. This is where the actual thing is. So we spoke about impulse, we started the discussion about impulse, that impulse as a definition is a significant force that is, quite measurable, and it has good meat, it has good value in it, right? That's what significant means. Applied over a brief period, very short point of time, results in a finite change in momentum. So that's the whole idea over here. So I introduced the entire idea that, it's not a easy thing to draw, and I drew extra graph and all of those, and I went on out of the screen, and I told that the time duration is very small, so it's not an easy thing to get. But what we can actually measure is momentum, right? We get to see that. We get to see, oh, ball was, if I have, like say baseball, I think that will be the best example. So we have, wait, how do they stand? They stand like that. The legs I'm not getting, but yeah, hand is somewhere over here. And okay, not a good. Okay, let me write just the bat. So we have the ball coming in. So it has certain velocity, right? And after the hit, it goes flying super fast. Both are super fast, and with some other value. So we can see this. We know the mass of the object, and we'll be able to figure out things. So it's much convenient, right? So it has a special name, that is, okay, not here. Yeah, it has a special name, impulse momentum theorem. So impulse in terms of momentum is what is more practical, right? But yeah, that is all introduction. The way we just saw was just introduction. We were just getting introduced to the idea of impulse being a product of time and force, right? Now let's start with this derivation. So as per, so this you can ignore, guys, actually. I'll put it over here. I mean, we not ignore it. We can, what happened? I think I deleted it. Okay. ठीक है, चलो, we'll continue over here. So as per, we have Newton's second law. An applied force is equal to what? Rate of change of momentum. So force can be defined as rate of change of momentum, or I can rearrange this as, or we can rewrite this as momentum, change in momentum is product of force into time, right? This of course we know. Next, for time 0 to t, let the momentum is a continuation, let the momentum change from P1 to P2. Now, so integrating one with above limits. What limits? Well, on the left hand side we have P1 to P2 dp, and on the right hand side we have 0 to t f dt. Okay, this is nothing but your impulse. This very idea is nothing but your impulse, and this is nothing but your p varying from p1 to p2, and this idea is your impulse, and therefore impulse is equal to p2 minus p1. Okay, this is also a simple expression. All you have to do is look at how things were before. Say I'm looking at the impulse that is acted on this object. So it had an initial velocity of u, and after some time, after delta t, the object moved something like this. So it had a velocity of v. It was moving like this, it went like this, and we won't be able to understand how much of force exactly it experienced, at least not directly. But it's much convenient to measure the speed. We can measure the mass, and so we'll be able to figure out the impulse. From impulse, we can do everything else, right? We have such a relationship also. We can figure out the average force, right? So again, we'll see numericals, then you'll understand. So funda is, this set of derivation should make it clear about the idea of impulse. So impulse as a formula, it's very simple. It's not a big deal. But as an idea is what you need to understand. Why is that we need it? Why is that? How useful it is, how often it is seen in our day-to-day lives. Okay, so you need to appreciate that, and then you will be able to apply it better. Whatever you're studying, you should learn to apply it. That should be the agenda. If not, there's no point. In the future, things will be more practical and less laborsome and more intellectual oriented. Right? Smart work. Okay, you can write the set of headings. And you need to write this. Okay, and then this.